Hello everyone, welcome back to my channel. So in this video we are going to discuss one question. The question is on the screen, where actually we have to use the method of separation of variables to reduce the given partial differential equation to a set of three ordinary differential equations. So here if you look into the question, the known function is t, where t is the function of r and z. So t is a function of two variables r and z. So it is not possible for us to reduce it into three ordinary differential equations. Instead, we can reduce it into two ordinary differential equations. Okay. So let us start. First, we have to write the equation. What the equation is given to us? Del square t del r square plus 1 by r del t by del r plus del square t by del z square is equal to 0. This is the given equation. Let us take it as equation number 1. Okay, now we have to reduce it into two ordinary differential equations. This is the given partial differential equation. Then what to do? So using the method of separation of variables, okay, let us represent the function t r z as a product of two independent variables. As t r comma z is equal to r r z z, where r is a function of r and z is a function of z. Okay, now what to do? Now we have to differentiate t with respect to, partially differentiate t with respect to r and z separately. Okay, so let us do that. Now differentiating t r z partially with respect to r, we get, what we get? Del t by del r is equal to, so while we are differentiating a function partially with respect to a variable, then the functions of other variables will be treated as constants. So in this case, because we are differentiating t with respect to r, z will be treated as a constant. So what we will obtain here? We will obtain dr by dr into z. Okay, differentiating again, equation again with respect to r, we get, what do we get? Del square t by del r square is equal to d square r by dr into z, dr square into z. So this we will get by differentiating drz partially with respect to r twice. Similarly, differentiating t rz with respect to z with respect to z, okay, partially twice, we get what we will get? We will get del t by del z is equal to, here because we are partially differentiating the function t with respect to z, so the functions of r will be kept as constants. So here r will be constant and we will get dz by dz, and del square t by del z square, because we have to differentiate it twice, is equal to r d square z by dz square. So let us take this as equation number 3, this as equation number 4, and this as equation number 5. Now using equation number 3, 4 and 5 in equation number 1, what you will get? 3, 4, 5 in equation number 1. Okay. So now using equation 3, 4 and 5 in equation 1, we get, what we will get? See, the first term is this one, del square t by del r square. Second term is 1 by small r into del t by del r. Third term is this one. So let us write it. First term is d square r by dr square into z plus 1 by r, now dr by d small r plus r into d square z by d z square equal to 0. Now look at the equation. This equation contains functions of different variables, means each term contains of functions of different variables. So here r and z, here also r and z, okay, z is there, z and r d to z by dz square. So we have to eliminate functions, those functions, okay, from each term. That means these two terms, if we look into these two terms, this contains a differentiation of r with respect to r, this also contains a differentiation of r with respect to r, but an additional function z is here in the form of a product. Here also this differentiation contains differentiation of function of z, but it contains an additional extra term of r. So we have to eliminate this r from this term and z from these two terms. In order to do that, we will divide the whole equation by rz. Okay. So what we have to do? Divide the equation by rz to obtain what? If we divide this by rz, z and z will be cancelled and we will get r in the denominator. So we will get 1 by r dr square plus, here also z cancel, we will get r in the denominator, we will get 1 by r, 1 by small r into dr by dr plus, in this term r and r will cancel, 1 by z we will get 1 by z d square z by d z square equal to 0. Now after obtaining this, now we can see that this term contains all the functions of r only. This also term contains either the variable r or the functions dealing with the r. And here also this contains z, which is a function of z. Okay, now what we have to do? We have to keep these terms containing the function of r on one side. Okay, and this term we will move to the other side. Why? To separate the variables. Okay, so what we have to do here? That implies we will get 1 by r take common, we will get d square r by dr square plus 1 by small r dr by dr is equal to minus of 1 by z d square z by dz square. Now look at this equation. Okay, this equation now contains terms of the same variable only, and they are separated now, distinguished now. Now we have to equate them to a separation constant. In this case, we will take a separation constant minus lambda square. Okay, separation constant we will take here. Okay, remember that. So what we have to do here? Okay, equating both the sides into a separation constant minus lambda square, we get, what do we get? 1 by r d2r by dr square plus 1 by small r dr by dr is equal to minus lambda square and minus 1 by z d2z by dz square is equal to minus lambda square. Now in this case what will happen, okay, this r will come to right side, it will become minus lambda square r. What you will get? D square r by dr square plus 1 by r dr by d small r is equal to minus lambda square r, and this minus minus will be cancelled, this z will be multiplied here, lambda square z, so it will become d square z by d z square is equal to minus lambda square z. On rearranging, we will get d square r by dr square plus 1 by r dr by dr plus lambda square r equal to 0, and in this case we will get d square z by d z square plus lambda square z. Sorry, this minus sign will not that means be here, okay, because already there is a minus sign this side, so this minus will cancel each other. Okay, so what you will get here? Minus of lambda square z is equal to 0. Okay, so these are the two required ODEs, ordinary differential equations, that we have obtained in this way. Okay, clear? So these are the required ODEs obtained from the given partial differential equation. Okay, so I hope you understood the concept. Okay, so like, share and subscribe my channel. We will come out with more such questions in the coming lectures with different concepts. So keep your notification icon on, okay, so that you will get notification whenever new lectures will be uploaded. Thank you.